study of F block elements. Now when we have seen the periodic table, in case of the periodic table totally there are four types of the elements: S block, P block, D block and F block elements. Now when we have taken as a F block elements, that time generally what happens here, if we have taken D block elements, that time generally here principal quantum number, this will be taken as concerned to here n, and again n minus 1 D can be taken as. Means if suppose we have taken as concern, that is principal quantum number 4 minus 1, 3D block elements will becomes. But in case of F block elements, here n minus 2 F can be taken as. If we have taken as concern, that is here in case of that is a F block element, there are two types of the elements. One is called as the 4F elements, again 5F elements. 4F elements are called as the lanthanides, again 5F elements are called as the actinides. And how 4F can be obtained? If we have taken as a 4F elements, that time generally what happens here, these elements lanthanides are present in case of the sixth periods. In the periodic table, sixth periods can be taken. This becomes as 6 minus 2, this equal to 4F. 4F orbitals, 4F block elements, they will be taken as concerned to lanthanides. And again generally what happens here in case of the actinides, there is n minus 2, means here totally 7 minus 2, here it becomes as a 5F block elements. That is lanthanides are 4F, actinides are 5F elements, and they can be studied as concerned to their introduction, electronic configuration, occurrence. All these points can be taken into considerations one by one. Now when we have taken, first of all you should take the lanthanides. Now what happens in case of the lanthanides? Along with the lanthanides, generally 14 elements comes together from cerium to lutetiums. That is lanthanum having atom number 57. This can be placed in case of the D block elements, and therefore totally they will be. But generally what happens here, the elements having after that is 58 to 71, their electron can be entered into the F orbitals, hence they can be placed in the F block elements. That is, these are called as the inner series of transition elements, and they are placed at the bottom of the periodic tables. Hence these are called as the 4F elements, or you can say lanthanides, lanthanons. These are the different names as per the lanthanide elements. And therefore 4F when you have taken, it will be started from atomic number 58 to 71. That is 58, that is cerium, 71 lutetium, that is as concerned, that is the lanthanums. And why these are called as the lanthanides? Because if we have taken the elements from the atomic number 58 to 71, the meaning is that from cerium to lutetium, all these elements can be collectively shows similar properties to the lanthanum. Hence these are called as the lanthanide series. And therefore just there is the properties are similar to lanthanum, and hence they are placed together with the lanthanum. And how they can be occurs, how the lanthanide elements can be occurs into the environment. Now generally occurrence can be taken. When we have taken as the lanthanide elements, they can be occurs within two groups. One is called as the ceride group, second will be gadolinide groups, or you can say totally cerides. Again yttrium groups can be taken. When we have taken as a yttrium groups, this will be taken as here gadolinide will becomes in case of the yttrium groups. Now generally how these ores can be obtained? Mostly you can say ceride means lanthanum, cerium, praseodymium, neodymium, samarium, europium can be occurs in case of the ceride groups. And if we have taken yttrium groups, yttrium group consists of the gadolinum, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. All these elements will becomes they will be classified into two groups by taking of the different types of the ores, and therefore these ores can be mentioned here. First ore can be taken as a ceride ores. Now when we have taken as the first three ores, cerite, bastanicides, monazite, these ore can be selected for the cerite groups. The elements which comes in the cerite groups will be extracted by taking off these three ores. That is, if we have taken cerite, Ce3, M second, H3, Si3, O13. Now instead of here M means metal. This metal M stands for calcium, iron. Both the metals can be taken having second oxidation state, 2 oxidation state, 2 plus oxidation state. And this ore consists of the cerium groups as concerned, that is 51 to 72 percentage. Means high presence of, that is cerite groups can be taken as the elements lanthanum, cerium, praseodymium, neodymium, samarium, europium. When we are going to extract, that time such ores can be selected. Now again you should take bastanicides. Now when we have taken as a bastanicides, this is also cerite ores. Means cerium group containing ores here CeF CO3 means carbonate type of the ores can be taken, and this consists of, that is here cerium 65 to 70% and yttrium less than 1%. Means mostly it can be for cerium groups can be taken. Again monazite ore can be selected in the phosphate forms when it consists of CePO4, cerium present as a 49 to 74 percentage can be obtained. Means this ore will be selected for the extraction purpose because it consists of mostly, you can say, in the phosphate form cerium group is highly present. For the extraction purpose, this ore mostly selected because it will be gives 74 percentage as concerned to cerium group elements, cerites. Now remaining three ores will be taken as per the yttrium groups. When we have taken as the yttrium groups, this consists of gadolinium, terbium, dysprosium, cadmium, erbium, thulium, ytterbium and lutetium elements. These elements can be extracted by using of these three types of the ores: gadolinides, xenotime, euxenides. Now here in case of gadolinides, what happens? The formula is Y2 M3 second oxidation state, Si2 O10. Here in case of M means metal, stands for Fe means iron, beryllium. These two elements can become in case of along with the silica. Mostly this will be consist of the yttrium group 35 to 48 percentage and cerium 2 to 17 means less. Again xenotime, when we have taken as a xenotime, this is specially for the phosphate. Again that is, this consists of the yttrium 54 to 65 percentage. Again euxenide, this will be the formula YNBTA TiO6. This will be consist of the water molecules, and generally that is 13 to 35 percentage. Means here that is for the extraction purpose mostly xenotime ore can be selected as concerned to yttrium groups, and therefore these are the occurrence of the, you can say, lanthanide ores. How they can become? Totally 6 ores can be taken. First 3 as per the, you can say, cerite groups, remaining 3 will be yttrium groups.